Hello and welcome to lesson 3.5 of Proving Lines Parallel. Now make sure that you have already done the vocabulary for this lesson, those postulates and theorems, and make sure those are in your vocab notebooks before continuing the lesson. Otherwise, let's begin. In the past, we've found slopes of lines and used them to identify parallel and perpendicular lines. Well, now we're going to identify parallel lines a little bit differently. We're going to recognize the angle measures that occur with parallel lines and use those to prove that lines are parallel. So our first postulate is the converse of a postulate you had in previous lesson, lesson 3.2. The corresponding angles postulate previously said if lines are parallel and cut by a transversal, then corresponding angles are congruent. Well, the converse of that statement says if lines are cut by a transversal such that the corresponding angles are congruent, then I can conclude that the lines are parallel. So all these theorems today are actually just the converses of theorems in the past that are now we're using those to conclude that lines are parallel. So if the corresponding angles are congruent, we know these lines have to be parallel. We also have the parallel postulate, which just states that if we have a line with a given point that is not on that line, there's only one parallel line through point P to line M. And then we have these other theorems that kind of go along with that corresponding angles converse. And so notice we're going to call these, instead of the alternate exterior angles theorem, we call it the converse, because we are concluding that the lines are parallel. So if alternate exterior angles are congruent, we know that the lines have to be parallel. If consecutive interior angles are supplementary, make sure you understand that, not congruent, supplementary, then the lines are parallel. If alternate interior angles are congruent, then the lines are parallel. And then we have the perpendicular transversal converse. It says, in a plane, if two lines are perpendicular to the same line, they have to be parallel. So let's take a look at example 1. In example 1, we are given this diagram. Lines A, B, and C are cut by this line going down through all three. And in example 1, they give us that angle 1 is congruent to angle 3. We want to state if any of these lines shown are parallel because of that. And we want to give a reason why. Well, 1 and 3, you'll notice, are corresponding angles on lines A and B. And since corresponding angles then are congruent, I can say that lines A and B are parallel by the converse of the corresponding angles postulate. All of this, we're going to write a little bit shorter. We're going to write that as the corresponding angles converse. Since 1 and 3 are congruent, A and B are parallel by that reason. Let's take a look at part B. Again, we're given some information about this same diagram, but in this case, we are told the measure of angle 1 is 103 degrees, and the measure of angle 4 is 100 degrees. Is it possible to prove that any of the lines shown are parallel? If so, state the postulate or theorem that justifies our answer. Well, 1 and 4 would be alternate interior angles, and they are not congruent because they don't have the same measure. 1 and 4 are alternate interior angles of lines A and C. Since 1 and 4 are not congruent, though, line A is not parallel to line C by that converse of the alternate interior angles theorem, or the alternate interior angles converse. All right, let's move on to example 2. And this is, in your notes, it says this is a standardized test prep. This is a type of question that's going to help you on certain standardized tests, like you might see on a final in our class or on a version of the ACT or a state assessment. And so we won't have multiple choice answers, but it is going to be a problem-solving skill that is going to be important on some of those tests. So we have this diagram for example 2. We have lines MN and PQ. Notice the diagram does not tell you that PQ is congruent or is parallel to MN. It doesn't tell you that. It may look like it, but we don't have any markings to show that. But they do give us these values. Now we should be able to recognize what kind of angles these values represent, as in what kind of special angle pair. And we want to show what value of that one of these angles would make these lines parallel. And so here's how we're going to solve this. And I'll bring the diagram back up in just a minute. Okay, we're going to solve this by understanding that these two angles are alternate interior angles, I'm sorry, alternate exterior angles. Okay, so we had WXP and ZYN, and in order for these to be parallel, if I can show these are congruent, then these two lines have to be parallel. And so that's what we're going to do. So we're going to substitute the given angle measures into the equation and solve for x. And once we know the value of x, we'll substitute back in to find that angle measure. So what I want to do first is assume that these actually are equal in length, or in angle measure, sorry. And that way I can plug in those values. Okay, so if you're looking back at this diagram, okay, we have 11x minus 25 is WXP, and 7x plus 35 is ZYN. And so I'm going to set those two values equal to each other. Okay? And then I can just solve that equation for x. I want you guys to go ahead and do that. If you need some more time, pause the video to give yourself that time, but otherwise we should get this for our solution of that equation. 4x minus 25 equals 35, and then if you add 25 to both sides, 4x is 60, and divide by 4, x would be 15. Now you don't have to give reasons for all of this, that's not really what we're having to do here, but we do need to remember that x is 15. Now what we're going to do is we're going to plug that angle measure in for this angle ZYN that we're supposed to be finding the angle measure of. Let me go back so you can see that. We want to find the measure of angle ZYN, which was that 7x plus 35. So we're going to plug 15 in for that measure. Okay? Since ZYN equals 7x plus 35, I just substitute 15 in for x. 7 times 15 plus 35 is 140 degrees. What that tells me is that the angle measure of ZYN of 140 degrees would make these two lines parallel when we were given that situation. So this is the answer we should get. All right, let's go ahead and take a look at example 3. All right, one final proof here. We haven't done proofs in a while, but this is a pretty short and easy one. Here's what we are given. We're given lines L and M are parallel. So that tells me certain things about angles being congruent or supplementary. If I know they're parallel first, I know angles are congruent or supplementary. I want to prove that these other two lines are parallel with the rest of this given information, that 1 and 3 are actually congruent. So we're going to start off, we're just going to write all the given information in at once. Go ahead and state that that's given. Excuse me. And let's take a look at what else we can know. Notice we mark angle 2 here. It's not in the given information. We probably are going to use that to help get to this. Well, let's look at the relationships between angles 1 and 2. If these lines are cut by transversal P, then 1 and 2 are corresponding angles. We are given L and M are parallel, so by the corresponding angles postulate that we had from lesson 2, I do know that 1 and 2 would have to be congruent. Now, if 1 and 2 are congruent and 1 and 3 are congruent, all these angles here, all three of these angles should have the same measure, because we have our transitive property that says if 2 is congruent to 1 and 1 is congruent to 3, then 2 has to be congruent to 3. And so this is what I'm going to state next. I'm going to say 2 is congruent to 1 because of the corresponding angles postulate, not converse. Converse is from the new lesson. Converse is what we would use to conclude that lines are parallel, but that's actually what I'm starting with. I'm concluding that angles are congruent. That goes back to lesson 3.2. But now I can kind of see how these have lined up here. If 2 is congruent to 1, and I already know 1 is congruent to 3, I can say that 2 is congruent to 3 by the transitive property. But then look at what kind of angle pair 2 and 3 are. If you consider M to be a new transversal, and these lines, 2 and 3, are alternate exterior angles. And in this lesson, we had the alternate exterior angles converse that says if two lines are cut by a transversal so that alternate exterior angles are congruent, then those two lines are parallel. So I can say that P is parallel to R by the alternate exterior angles converse. All right, we're going to do some more of these proofs. The majority of what you'll notice in the assignment doesn't consist as much of the proof as it does the problem solving. We're going to do some more of that in class, so you should have a pretty good start on understanding lesson 3.5.